So in the first part of the notes, we were only tackling one-step conversions. The one-step conversions aren't very typical of what kind of questions you would see in this class. So we're going to step it up a notch and look at our multi-step conversions. Something you want to make sure of when tackling multi-step conversions is that you're fully aware of all of these conversions that you were given prior to starting this unit. So you have to have all of these conversions memorized by test time. I mean, it's okay to use it as a reference during class, but you definitely by test time, by quiz time, you need to have these down. The other thing that's also available to you is during the test, during a quiz, this conversion factors square is on the back of your test copy of the periodic table. So make sure you reference this as well whenever you're looking for specific conversions. So the very nice thing about dimensional analysis is sometimes you can be going through a problem and you may not know if you're doing it right or wrong, but if you cancel out all of your units and end up with the unit you need, you know you did the problem right, assuming all of your ratios are correct. So let me show you what I mean by that. If you have this particular problem, if you're trying to convert 323 milliliters to cups, first you want to realize what type of conversion this is. We're talking about a volume conversion, and we're actually going from a metric volume to a USCS volume. So because we're still in the early phases of trying to figure out all of the conversions, I'll just go ahead and have this up as well as the other piece from your conversion chart just so we can scan it for whatever conversions are going to be useful for us in this problem. All right, let's have the side by side. So as we're going from milliliters to cup, one of the things I like to say is try to create a pathway to get you from milliliters to cups. So when you're scanning your conversions, here are volume conversions and volume conversions, look for milliliters and cups. I see milliliters in this conversion. This will take me from milliliters to liters. And I also see milliliters in this conversion. You're not going to be using both of them. You have to learn to train your brain to pick out the conversions that are going to be most useful to you for the particular problem. So since this takes me from milliliters to liters, I might want to see how liters may take me to a USCS unit. And as I'm looking at the back of the periodic table, I see another conversion that will take me from liters to quarts. And I know just from common knowledge, quarts can also be converted to cups. So there's my pathway. This conversion to take me from milliliters to liters, this conversion to take me from liters to quarts, and this conversion to take me from quarts to cups. So all of those ratios are going to be used in this problem, and here they are. Milliliters to liters, liters to quarts, quarts to cups. So in all problems, you do not have to list out this GWR that I've been introducing to you in the earlier videos. This is really just a way for you to organize your thoughts. I like it, especially when we're in early stages of dimensional analysis, because it gives you something to work with, but it's not 100% necessary that you do that. All right, so we're going to start our dimensional analysis problem the same way we always start, with the given over 1. So there's your milliliters. There are 323 milliliters over 1. And we want our milliliters to cancel out with milliliters. So as I'm scanning my ratios, I will take the ratio that has the milliliter unit in it, and I'll place it diagonally from the other milliliter unit. Since this conversion, the other side of the conversion is equivalent to 1 liter, I put that in the numerator. So everything above and below each other is going to represent a ratio or a conversion or relationship, same thing. Next step, I need my liters to cancel out with my liters diagonally, so I'm going to take this part of the next ratio, and my 0.946 liters goes in the denominator, 1 quart in the numerator. Remember, whatever is above and below each other, it represents one ratio. And final step, I'm going to take my 1 quart, put it diagonal at the bottom, 4 cups at the top, and now I know I've completed my problem. When all of my units cancel out diagonally, leaving me with the units I am interested in. So I wanted cups in the end, and I have cups, which is great. Now, to get this numerical value, you want to be very careful about the way you're typing numbers into your calculator. My best advice to you is whenever you see a number in the numerator, you're multiplying by those values. Whenever you see a number in the denominator, you have to divide by each of those values. We should know by now that anytime you multiply or divide by 1, it's itself, so save yourself the calculator button pressing and just skip all the ones. So here's how I would type this into your calculator. 323 divided by 1,000 divided by 0.946 times 4. I have to make sure to hit the division sign for each of the values in the denominator, or I could put the denominator all in parentheses, whatever your preference is. Like when you go back to the earlier videos, you can see the sequence, like the initial steps you would take to like figure out how to type this stuff into the calculator. That's like earlier dimensional analysis stuff, but I just want to make sure that we're clear on how to type this into your calculator, and this is what your calculator spits out. We want to also remember our sig fig rules. Since this initial number here, the given, has 3 significant figures, I'm going to take, let me back up a little bit, I'm going to take this value, I'm going to round it to 3 sig figs, 1, 2, 3. The 6 is sitting next to a 9, so this actually ends up rounding up to a 7. And my final answer is 1.37 cups. Cups is my final unit, not only because that's what I was trying to solve for, but because every other unit canceled out, leaving me with cups in the end.